All right, the second half, we're going to basically have some examples where we have to use permutation and combination. So let's get those formulas. So NPR is equal to n factorial over n minus r factorial. And remember, for permutation, order matters. So think back to that locker combination. And then for combinations, so we have NCR, n factorial over r factorial over n minus r factorial. And on combinations, order does not matter. So when you're reading through, you're supposed to first figure out if it's a permutation or a combination and then answer the question. So it says a group of 35 runners are going to run a race. So we know this is our total number of people. The top 3 runners earn gold, silver, and bronze. So when you're thinking about this, do you think the gold versus the silver versus the bronze matters? And the answer is yes. So because they're placing, the order matters. So since order matters, we know it's permutation. And it's 3 positions and 35 choices. Sorry, 35 options. Can't use choices. So 35P3. So that looks like 35 factorial over 32 factorial, which will give you 39,270. Next example, a group of 30 people are going to run a race. So we know 30 is our total. The top 10 finishers advance. So in this case, it's just the top 10. Nobody's getting distinguished by first place, second place, third place. So because it's just the top 10, order doesn't matter. So if you come in first or 10th, you all move on to the next round. So this will be a combination. So we will do 30, choose 10. So 30 factorial over 10 factorial, 20 factorial. And that should simplify to be 30,045,015. All right, 2 more and then we're done. All right, a dodgeball team of 12 players. So 12 different players, that's our total. 2 players to choose the refill, to refill the water. So these 2 people, doesn't matter if you're the first or the second of those 2 people, the order does not matter. So we're back on combination again. So there are 12 choices and 2 people. So it will look like 12 factorial over 2 factorial, 10 factorial, because remember those got to add up to give you that, and it should be 66 different ways. And then lastly, you're setting a combination on a 5-digit lock. So that's the total number is 5. And you're going to use these specific numbers, 1, 3, 5, 7, and 8. Here's the tricky part on this one. It says you don't care what order they're in. But think about a lock. Does the lock care what order they're in? And that definitely is a yes. So if I had the combination 1, 3, 5, 7, 8 versus 5, 3, 1, 8, 7, these are different and they matter because you're trying to open a lock. So order does matter here. So we're back to permutations. So we have 5 and we have 5. So 5p5, which is just 5 factorial basically because you'll have it over 0 factorial. Oh, I can write it, but that's just 1. So 5 factorial is 120. So 120 different ways to make a 5-digit lock.